There you go. Then I'm going to pull some resistors. Put one here, put one here. Then I'm going to pull some voltage sources. Okay. Put one here, and then put one here. Pretty cool? Mm-hmm. Okay, so now I can go to some values. So I'm going to call this one VBB. I'm going to call this one VCC. I'm going to call this resistor RC. And this resistor RB. I need a ground as a reference if I'm going to use the, what do you call it, the simulator. Let me go down to here. Great, let me save this file as, file save as, in that directory. And this is here. Let's call it NPN 2N3904. I'm going to be picking that up, basic circuit. Basic bias. So, I'm going to pick my transistor, pick a transistor, and 3904 happens to be right here. And it tells me right there what it is. It's maximum VCE is what? 40. Maximum current, 200 milliamp. Okay? So you can actually scroll through this and it will give you some more information. We're going to learn about most of this stuff here, right? And where to find beta, which is really the same spec sheet that you just saw. I'm going to say okay. And, oh, I hit cancel, didn't I? So 39, I'm going to say okay. There. Now we got it. Now I'm going to go over here and make this one 15 volts. I have that. I'm going to make this one 5 volts. I can do that. And I'm going to make this one 1 kilo ohm. I can do that. And I'm going to make this one what? 45K. Now we test it. And we see if we're getting these values. But before I do that, here's what I'm going to do. I'm going to get some points. Collector. I want the voltage at the collector. I want the voltage at the emitter. We don't need the emitter. And I need a voltage at the base. Well, just in case. So change this to base. And change this to emitter. So we know emitter is to ground anyway. So VE itself will be 0 no matter what. But everything is up to from, if you say, you see something says VC, it really is VCE since E is at ground. Does that make sense? Okay. All right, ready to run it. Let's see what we get. And we're going to do DC up. And I'm going to say okay. And there we go. So let's see if we're any close. Aha, I am. Notice IC is about 15 milliamp right there. Is everybody with me so far? And let's figure out our current at this stage. This is max. So can you see what VC is? Let me move this here. Where am I? VC is VCE, isn't it? I'm at 0.1 volts. That means I'm at this point. I am right here at saturation. You with me so far? So that means this is telling me I am saturated. It's almost 0, isn't it? 0.1 volt. And I'm getting what? 15 milliamp. I am right there. Does that make sense? And now can we figure out beta, by the way? Yeah, I can, what is it? IB right here. It's 0.9 microamp. So take your 15 milliamp divided by 0.9 microamp. Give me beta.
Where did you find 0.9 again?
Yeah, so 0.9 is right here. So you got 9 point something 10 to the minus 5.
Yeah.
0.9 10 to the minus 6. Always go in micros and picos. Try to keep it in powers. Powers you can clean up. So because milli and micro can clean up real quick. Does that make sense? Yep.
Would it be 0.9 10 to the minus 4?
No. If you move this here, you're going to have to. Oh no, you're right. It's 90. Let me see here. 94 milliamp. Move the 0. So 94 microamp. Does that make sense? 94 microamp. So 94 microamp. So you have 15 milliamp divided by 94 microamp. Where do you end up? Okay, right around the 150 range. We're pushing it. Does that make sense? So we're right on the money. Does that make sense? And other things we could quickly check if we were to do these calculations. If RB was 45 kilo, can I figure out what IB is from that? Well, I know what IB is. IB is going to be equal to well, we could do it based on the beta, or I could do it based on these values. 5 minus 0.7 divided by 45K, 10 to the minus third. So everything becomes 10 to the third. So calculate this for me. 5 minus 0.7 divided by 45. Minus third. 5 minus 0.7, it's 4.3 divided by 45. What do you end up with?
95 micro.
95 micro. Pretty darn good, isn't it? We're right on the money. Does that make sense? And this is at an extreme. Do you agree? So I know I could say the minimum value I need is what? 45, and this transistor is definitely saturated. Can I control this transistor by changing the value of RB and leave everything alone? Does that make sense? So I'm going to go from 45 and add resistance to it. Why? Because I want to lower IB. And if I lower IB, I lower IC. And if I lower IC, I increase VCE. You with me so far? Notice this proportionality here. What happens as IC decreases? VCE increases to a point where I'm going to be somewhere around here. We're going to see where we are. Has everybody seen the physics of this? Do you see why I sent you to a corner before? Right? So to understand these relationships, now they're starting making sense as to why we need them, so we can craft these circuits. We can put them together. We can do our controls or amplification. And okay, so now we can play. We can play here with RB, so I can close this. So I've got 45K minimum. Great. Can I move up and see what I can do? All right, so 45K, can I go to 100K? Let's go to 100K. Now, if I run this, I should be somewhere in the operation. Does that make sense? VC is no longer going to be 0. Right? So, that's right. And sure enough, I moved up in VC. Do you see VCE? So, this is 15 volts. What is this? 7.5. 1, 2. So I'm right around here, 2 volts. Do you agree? If I'm right there at 2 volts, what is my current? I see 12 milliamp. So instead of being 15 milliamp, now it's at what? 12 milliamp. And this is where my Q point is. It's got 2 coordinates, 2 volts and 12 milliamp. You agree?
So, which one did you?
So I picked 110. It allowed me to lower IB, which lowered IC but increased VCE. The relationships. Does that make sense? If you get those relationships, you're on your way.
Where do you find VCE on this?
Right here, it's VC.
VC, or
VC is VCE because E is already to ground. Does that make sense? Right? So let's go to the circuit again so you can see it. E is to ground. So everything is relative to ground. Does that make sense? If I run this, it will show that VE is 0. It doesn't even bother with it because it's grounded. It just needs to worry about VB and VC. Notice VB is VBE, 0.7 volt. Now, what if I wanted to be smack in the middle? About, what's half of 15 milliamp?
7.5.
Yeah, so somewhere around there. Knowing that I have, oh, by the way, can we check right here, based on these results, what beta is? Real quick, you just divide what? IC by IB. You take your 12 milliamp divided by 42 microamp. Does that make sense?
That's how you find beta?
Yeah. All day. And you can see that it's still within that range. Does that make sense? What are we coming up with?
Like 286.
Right. It's skewing too much. We'll do it in the lab and see what it will do. And I have a feeling something is. And this is based on its characteristics, it's doing this. So we'll see why it's doing that. But, well, let's keep going. Let's keep going with, just make sure the math is correct. This is 12 milliamp divided by 42 micro. -6. What you're getting?
Got 28. 200.
280.
85.
Okay. All right, well, let's go to 500K. Let's see what happens. So, let's run it. And I am smack in the middle. Well, not smack in the middle. What's smack in the middle for IC? To be, so we need to be less than 500K. Let's go for 250K. Let's run it. Yeah, I can even go lower. Let's go to 200K. Yeah, that's good. Right there. So what am I end up with? 6 milliamp. Do you agree? About 7 milliamp. And 21 microamp. Can you do the ratio for me? So it's close to 300. So let me check something.
I got 286.
Yeah, it's yeah, but that's probably what it's going to be. Ah, here he is. because we've changed our characteristics. It's right here. It's not, 150 was just an estimation that I made wrong because I picked the 03. It's the 04. Right. Does that make sense? Yeah, so I was blind. I couldn't see what I was doing. So it's the 04, which is around 300. Does that make sense? So yeah, we're doing fine. So I was wondering, what's skewing? All right, so we're good. Got it?
So even though we're not close to that one at 350.
No, you're going to be at 300. Yeah, near it.
Oh,
It's going to be between 100 and 300. Does that make sense? Right. So I just picked the wrong component. I picked 903 instead of 904. What we have here is a 904. Does that make sense? Right? So, yeah, so the values are just fine. Everything is fine. So, at this stage, let's see where we are. Let's see this Q point. Right here. I've got 8 volts. So it's 8 volts is going to be here. So let's call that one Q1, Q2. And I want to know where Q2 is. Does that make sense? And what's going to happen with Q2 is you're going to end up with 7 milliamp. This thing is dead. So basically 8 volts and 7 milliamp. If you draw a graph with these points, you'll see it's a straight line. Does that make sense? That's called the load line. And your Q point can be anywhere within that load line because there's a factor of 300 between the primary and the secondary part of the circuit. The link is that beta. Does that make sense? That's a key factor for the transistor. It's a current controlled device. You control the output current with the input current, knowing that they're related with beta. So the biggest formula that you need to extract out of all of this is this. Does that make sense? And we've proven it. It's just a matter of finding beta. Beta is going to be depending on the spec sheet. So there's a range for it. So it's not always a fixed number. But once you have it, it's going to be the same across. Okay? So good. Now, let's see. Let's do another one. So let me save you this.
When going back and fixing B, we ended up with 100K.
Yeah. So that should have been a what? Instead of this one, this should have been at 100K if this was a 300. Yep. So 300, and this would be 100K minimum. Yep. Good. At 45, we were already saturated. Does that make sense? We were below 100K. 100K is your minimum, and then you start anything above 100K. Right. All right. Well, let's do another example. Let me save this, send it to you, and then we'll do another example with another transistor. Let's see if you can get the specs and work with it. Does that make sense? We're going to pick the 2N222. 222, 3 twos. The first time I've used that one, it was a 2N22222, was 1978.
Good number.
Oh, yeah.
How old are you then?
Oh, God. 15, maybe 14?
You were young.
Yeah. I had a lab. Beside, I had an electronics lab plus a photo lab. I was
Yeah, no.
I lived in the mountains. There was nothing else to do. Yeah. Yeah. So. And
What state?
not. I was overseas.
Overseas?
Yeah.
From where?
Algeria. Yeah. So. All right. So we got this. We're gonna do another example, right? So the 2n, which one?
222.
Okay.
And you said that we were.
Right, so- Let me save this one. Did I save it? And let me give it to you. So we're gonna go back here. Let's go to files. Today's session. What are we today? 10 to 24. So go here. Choose file. And it's this one right here.
Is it top one?
Let's see, that's the raw files, LT schematic. Open it on your end. Make sure you have it. Just to double check I'm sending the right files. Is it coming out blank?
Yeah, it's like reviews available.
Huh?
But you might have to download it.
Yeah, I'm able to download it and open it on Etsy stores.
You got it?
Yeah.
Okay, good. You're gonna check your system, see why it's not coming out.
It works. No, it works. You just have to download it and open it in Etsy stores.
Good. Good. So what I'm gonna do now is go back here. Oops. Where's LT Spice? Right here. I'm gonna remove this voltage source, the value. I'm gonna remove this guy. Well, I'm gonna leave this 15 because that's your trainer anyway. Does that make sense? So I'm gonna leave that. I'm gonna take that 1K out. You have to decide what you wanna do. I'm gonna take the 200K out. And I'm gonna change my transistor. There he is. And notice here, max voltage of 30, no problem, at 15 we're good. This one operates at higher currents. It's a bigger transistor, it's a little thicker. Does that make sense? So that's almost 0.8 amp. So there, all right, redo. What does that mean? That means go online, look for a spec sheet for this transistor, you can do that, and then work backwards. Does that make sense? Start with saturation. That's your strategy. And then you figure out what is the minimum RB value you need, and then start increasing RB from there. Got it? So this here.
Yes, sir. It's cool. I plug this in real quick.
Yeah, yeah, go ahead, go ahead.
Screw that. Move this quick.
So pick where you want to be at saturation. So your results are going to vary depending on what you pick for saturation. Does that make sense?